Let's talk about, visualizing assertions for complex logic tests. So if this is not the talk you are here for, please stay nevertheless. Thank you. So I'm going to take all of you, hopefully, for a ride. So it starts at the starts, it ends at an end we hopefully don't expect yet, but let's see how we get there. So my name is Mario. I'm a developer evangelist at Deutsche Telekom. What does Deutsche Telekom do? We do things with SMS, voice, 5G, and other beautiful other things. I mean, this is fine by itself. I joined because I really like developers, right? And I took the opportunity to say, Deutsche Telekom, can we open up your APIs you have internally for the external developers? So we are in the process. Please don't ask me about timelines. But we are in the process, which is already a good thing. Yeah, I took a look at one of the simpler APIs for now, which is the SMS API. And I'm curious to see, like, SMS. We all probably know what is SMS, but why do I think it's fascinating still in this time, right? SMS also works when you have no internet, right? It's like if you are on top of the mountain but have a GPRS connection or any kind of connection to a network, to the telephone network, you can still send and receive SMS. So this is great. And usually you get SMS when, like, you get a ton or you need to log in into a web service or something, then you also get an SMS because it's considered something urgent. Another thing I wanted to explore is, like, it's kind of fascinating to see how the ancient technology worked with something like character encoding. So that's why I took a look at this one. And so since we were talking about, like, something that needs to be really, really urgently solved and reacted to, I obviously had to think about playing chess together, right? So the idea is we play chess, I make my move, send you an SMS, you receive the SMS, and then create and react on my move. So this is the idea, but how do we implement this from an Android point of view? How do I send an SMS that contains the state? The easy part there is, like, we can find a way that we can put the state of the chessboard into a string, zip the string so that we make it a bit shorter, and then we have to also base 64 it so that we are in the character set the SMS can send out. Hopefully as a surprise to no one, the other way works the other way around, right? So, like, you receive the SMS, you click on the beautiful, beautiful content URI, which contains then the hashed, zipped state of the chessboard. And then everybody uses Jetpack Compose, to actually build this beautiful, beautiful app, right? Yeah, okay. This was your cue, by the way, Mexican nod, thank you. Also, you see, this is a vertical grid, right? A lazy vertical grid that contains just a text view, and on top of the text view, you have the UTF-8 characters for chess. So, like, the pawns, the queen, the king, all of them are just one character on the board we are seeing here. Also, what you see in the beautiful magenta color over there is the actual URI we are sending as an SMS. With SMS, you can send 160 characters. This, roughly, depending on the zip encoding you're using, is 100 characters. So this should be working fine for now. So let's assume we have implemented this app. How do we make sure that what we implemented actually works? Now we're getting a bit closer to another topic we want to talk about, is, like, how do I validate the moves? Like, how do I validate the game is over? How do I understand that the thing I'm getting from the external source is an actual chess state? Ideally, we do it with something called unit testing. Somebody heard about it, this one? Sorry. And when we are trying to express this state, we usually have something like this, right? So we are saying we create a chessboard where the white king is in the center place on the chessboard. And then we see, like, what options for a move do I have? Well, and then once we have established the options, we check it towards a validated list of like, those are the indexes on the chessboard the king can move to after the user clicked on it. Who knows if the 37 is right? Exactly. So for this one, I thought like maybe we can over-engineer the solution and like find a way that we can visualize it. So like something like this would be kind of nice, right? So like I put it in a test and I can immediately see like, yes, this is how my chess piece should be moving. In this case, it's the king, and the king can only move one step in all the directions. Well, and the keen eye already found out this is actually a text string, right? So like what you're seeing right now can be expressed in Android by even smaller font sizes. So like if you can't see it, just feel free to step even closer. And if you use raw literal strings, you can actually put the state of the chessboard in there and then validate that it works. You also see the nice little extension function there, which is called toPrettyString, which I will talk about in a second. But when we are putting everything on strings, comparison is actually easy, right? So like you see in the actual part of the diff right now that there is a piece that is not, like there is an option that just our algorithm didn't provide, even though we specified it should. And through the diff tool on Android Studio, you can see like, wait, in line 5, there is something wrong, so I have to take a look into the direction the chess piece moves. So this is kind of nice. This is the visual approach I like to follow it because it makes it so much easier to understand what's wrong. I already teased the pretty string, so let's take a look at some implementation of it. Especially this part here is, like, we assume we go through a list of cells of the chessboard. And we find out, like, if this cell is empty, right, so there is no piece on it, we find out, okay, if this cell is empty, is this one of the options? Is this one of the indexes we were looking at that the board can have for options the user can click on? And if it is, we return in this piece a string that is just an empty dot, another nice UTF-8 symbol. But if it's not part of the options list, we just return the appropriate colored chessboard color, in either black or white, another UTF-8 symbols in the last line. And at the last piece, in order to make this all right, if this is a cell that contains a piece, we just render the piece into a string, have one character there, and then can follow up. The last line here is just making sure that also a new line is happening. Without this, you would just have one long string and wouldn't be seeing through when the new row starts in the chessboard. So with this one, like we have done like parts of the talk, right? So like we have done our over-engineering. This is now a sample ad for the SMS API. You remember this is where we are coming from, that we can release and actually like bring out to the public once our APIs come live, because it uses the SMS API, it's over-engineered, and we all like to play chess, right? But maybe that's not all. Maybe there is even more we can do with this kind of approach, where we are thinking like, how do we visualize things to make it easier for us to follow on where the error lies? And with this one, maybe there is something we can use with Android tests. You know, like this thing you have to run the emulator for, that it then runs on the emulator or the connected device. Because maybe here we can use the image of a view to actually compare to some kind of text. Also, water's great. I recommend water to everyone. Usually we have those similar tests existing, right? We have a ground truth, we compare the ground truth, but when you're reading those tests with images somewhere, you never see it in place where is the error. You always have to open the ground truth image, and it's just like more cumbersome than I think it should be. Also, it's very brittle. Like if you move one button to 1 pixel, it immediately fails because it's not the same image anymore. So maybe we can also abstract it and make it a bit more coarse. Oh yeah, also beautiful animations. Also the slides are over-engineered. I hope you noticed. So let's follow this way, right? So we have Android views. maybe we can, from those Android views, make pixel images, then build some kind of character mapping where we decide like which UTF-8 characters do we want to have and how do they map to grayscale images. Then we cut the image and then we compare. How do we get the pixel image of a thing inside a unit test, inside an Android test? Well, luckily there's the Jetpack Compose testing library for UI, where you just define the rule. In this case, it's create Android Compose rule using the main activity. And with this rule, you can ask every view you have a selector for, like, to render an image of itself. So in this case, we just say, as an example, test rule on root capture to image. This one returns us an Android image, and we can do fancy things with it. Now we have the image, but how do we get the character mapping? How do we get from character A to its UTF-8 representation, and then there to its grayscale image? The beautiful answer is image magic. This is a command line tool. I'm just going to zoom in a bit more. That has over-engineer, just saying. That has a Pango filter. This Pango filter uses an XML description on how to put UTF-8 characters onto the image, which you see in the first line. You can define its size. And then you just tell it to make it gray, invert it, because like usually when you write text, it's in black, but you want it in white, and the background should be. Then you do some more magic with it, because like image magic also can not only convert images from whatever type of image format to another one, but it also has something called a text format. So txt : means that it puts out every pixel on the command line in its color values. And then once you have this one, you already have a text representation of the letter A. You just need to do some more magic with SED, finding out the new lines. And at the end, you come up with the beautiful character map I was showing you over here, right? So you can create JSON from scratch if you like to, and there is a tool that can do it. If you want to take a look at even more source code from this one, feel free afterwards. I will share the code. So now we have the character map, right? So we know how a character looks in the grayscale. And we need to do now the other side. How do we take a look at the image, right? We want to now split the image into the character sizes, right? So like we go through the image and cut it into regions that are the same size of all of the characters we have. And in this case, this is really simple Android bitmap manipulation. You go through all of the regions, cut them out, and then transform it into the grayscale. Now you have two grayscales. You have for every region of the image a grayscale image, and you have all of the grayscale images of all of the characters. Now you got to compare. How do you compare two images? In this case, since it's grayscale, I just took the usual difference. I go through all of the pixels of all of the regions of the image with all of the grayscale images of all of the characters we have in our big, beautiful JSON file, and see when I sum those pixel values up, which one has the smallest difference. This is then hopefully the character that is closest to the region I want to represent with a character. Who's still with me? I see a hand. Great. Thank you. You get your money later, no worries. And now let's get even more visual, right? So like now, once we go through all of the steps of creating the character map, creating the image, creating from the character map the image that is representable by a string, we see something like this. So this is an Android test, right? Where I can say, does the beautiful block with like something that looks like a chessboard with chess pieces on top of it compare to what my test returns me at this stage? To add more visibility to it, I come to the scaling part of the image in a bit later, but this is essentially the difference, right? So like now you could have two tests. Like one is representing one state, which is the normal one, and then you can have another one that represents a state with an additional button to it. And whenever you find out like that in the second image that there is no button, this means something in your logic failed, and you can immediately see like I have to take a look for the button and not find out what is the actual ground truth image and how do I find out what is the actual error. do you see? This is the idea, to make everything more visual, right? I don't need to rely on random values or random images that I can somewhere. I can directly see it, where the error happened, and I don't need to think about what those indexes or whatever I want to represent stands for. Obviously, there are downsides to this approach. Like, don't get me wrong, it's not all rosy, because I always need to have an emulator running, or at least have a connected device, because I didn't find another way how I can render a view in Jetpack Compose, except for having like Skia or something running. I don't know if the compiler can also compile to something else. That would be kind of interesting. And I showed you obviously the happy case, right? So like if you want to render something that is a very huge image into text, this approach takes way too long because it cuts too many images and it also doesn't scale with the character set, right? So if you want to have like the whole set of UTF-8 in there, this would not scale because it would take too many comparisons to find out the right image. Now, this is actually ending up into the question is, like, what are you going to do with it? So, like, if you have the power now of trying to visualize all of your tests or all of the assertions you have, how would you use it? Are you excited about the SMS APIs, which I started with? I am very excited, and I'm sorry that I have to bring it across so often. One more time, this one, if you are very excited, talk to me, because you can be excited and get paid for it by becoming an evangelist for the Deutsche Telekom. I also have to ask you the question, like, if you come to me and tell me what is your favorite UTF-8 symbol, this would be a great conversation starter, I hope. But with this one, I'm probably over with my time now. Thank you for your attention. Thank you for staying with me during this talk. And I'm happy now for your questions and your suggestions. Thank you so much.